They all follow a secret pattern, and by the end of the session, you'll know exactly how to decode it. Okay, let's dive into this.
Here's our roadmap. We'll start with the basics, build up to the essential tools, solve a real problem, and then finish with a quick-fire challenge.
Let's start with a simple idea from your textbook: simple interest.
Notice anything about this sequence? Each year, the interest grows by the exact same amount, 80 rupees. This consistent step-up is the key idea we'll be exploring.
Now, let's give this pattern a formal name and break down its parts. It's just a fancy way of saying we're adding the same number over and over again. So the crucial point is the difference must be constant. The sequence on the left is an AP, but the one on the right is not, because the step isn't the same every time. For our interest example, the first term A is 80, and the common difference D is also 80. Simple as that. What if we wanted to find the interest after 20 years without writing out all 20 numbers? There's a tool for that. Let's move to and see how this builds. This formula is your first magic wand. It lets you find any term in an AP without listing them all out. Now, what's really interesting about this slide is how it breaks down the code. AN is your goal, and A, N, and D are the pieces of information you need to find it. Let's use it. We identify our starting point A, our step D, and our target N. Plug them in, and you find the 10th term is 800. Easy. Okay, but what if you need to add up a bunch of terms in a sequence? For that, we need another tool. This looks complex, but it's a huge time saver. It helps you find the sum of a certain number of terms in an AP. Now, let's put our new tool to work on a fun problem straight from your textbook. This is a classic AP problem in disguise. Let's break it down step by step.
First, we see the distances for fetching each ball form a sequence. The distance increases by 6 meters each time, and this brilliantly illustrates an arithmetic progression. We have our 3 key ingredients. A is 10, D is 6, and N is 10. We plug these values into our sum formula and solve. The total distance the runner has to run is 370 meters. Here's a quick summary. If you want to find one term, use the top formula. If you want to add up a series of terms, use the bottom one. All right, time for a quick test to lock in what you've learned. Pause and think after each question. The answer is 4. The sequence is going up by 4 each time. The answer is 25. It's 5 plus 2 steps of 10. Think about movie ticket prices in a theater, the layout of seats in a stadium, or even a weekly savings plan. Keep an eye out for patterns. They're everywhere.